Okay, on Tuesday we did some examples. They were related to if you have more than one gradient on your segment, what can you do with the, how can you combine the gradient? And then there was one example for freeways where we found the level of service. Okay, so that was the operational analysis for freeways, and then we also added the adjustment factors for weather in the same example. Okay, so we saw what things will change because of the adjustment factors. Today we will do a couple of more examples. This one is for a multi-lane multi-lane highway. You have 4 lanes. It has a median. Okay, so the highway which has a median is called a divided multi-lane highway. So this one is a divided multi-lane highway. It has a volume of 2,600 and lane width 12 feet, 4 feet letter clearance on road side and median side. So 4 here, 4 here. It has 10% trucks with a standard mix. Okay. Standard mix means what? Single unit trucks are more. This is what we call a standard mix. Okay. Standard mix means we have 2 types of heavy vehicles: single unit trucks and trailer trucks. Standard mix says single unit trucks are more. Okay. And what else? Peak hour factor is given. We have a gradient of 3.5% in a length of 125 miles. Okay. And the free flow speed is 65 miles per hour. They are asking for level of service. Okay. In these examples, what is our first step? Always. We did it in the previous example as well. What is always our first step? Yes. The first step is to find out what? What was the first step in the previous example? Free flow speed. Okay, the first step is always find out free flow speed. Okay, should I find it? We have it. Okay, but this one is base free flow speed. Okay, so there's a difference between free flow speed and base free flow speed. Okay, this one is base free flow speed. So we have to find it. We have to find out the free flow speed. Okay. Free flow speed for multi-lane highways. This. Okay. This equation. Okay. The value which is given is base free flow speed. So this value is given. Okay. Then I need factors for all these things. I need factor for lane width. Lane width is given as 12 feet. Lane width is 12 feet. So the factor is how much? 0. Lateral clearance. There is a table for lateral clearance of multi-lane highways. You have to use this one, okay, not the other one. I have 4 lane highway. So the first 2 columns, I have lateral clearance 4 feet and 4 feet. Total 8. So what value? 0.9. Okay. Then I need factor for median. I have a median. That means my highway is divided. So the factor is how much? 0. Then I have access points. I have 10 access points per mile. So my free flow speed how much? 61.6. Okay, so the first step is always to find out the free flow speed, which I did. Okay, second step is always to find out what? Huh? FHP. You wrote it? You wrote it? Very good. Okay. FHP equals to this. Okay. FHP equals to this. So it depends upon terrain conditions. We need percentage of heavy vehicles, which is given. And then we need EHV factor. EHV depends upon terrain. Okay. What is given about terrain here? G and L. Okay, so I need to decide whether I have general terrain or a gradient. Okay, so if you look at this flow chart, is my gradient less than 3% or more than 3%? More, so I am in this box. Okay, then my length should be more than 0.25 miles. Is it more than 0.25 miles? Huh? Yes. So we have gradient. Okay, we don't have general terrain. Now if you have gradient, then you can use this table or this one. Okay. It depends upon what mix you have for heavy vehicles. They are saying what? Standard mix. Okay. For a standard mix, we use the first table. Okay. Maybe they will call it a standard. They will call it typical, default. All of these things means the same thing. Use this table. Okay. Or practically they mean that single unit trucks are more, trailer trucks are less. This is what standard mix is. Okay. But we have to use this table. So my gradient is 3.5%, which is here. My length is 1.25 miles, which is this one. Okay. And what is my percentage? 10%. So I'll go to 10%, which is 2.96. So my EHP is 2.96. Clear? Anybody has a question in front of them? Can you look at the question if you are doing? Open the question. Yes. Can you read the last line? What does the last line say in the question? Huh? What is the expected level of service? And? Upgrade and? Downgrade. They want level of service, upgrade and downgrade both. Okay? They want level of service, upgrade and downgrade both. You calculate EHV, you found the EHV for what? Upgrade or downgrade? This is up. Okay, you can see all values are positive. So this value is for upgrade. Where is the downgrade? Huh? Where is the downgrade value? Huh? Yeah, this table, same table. Where is it? The first line. Okay. Less than 0. This one. Okay. Less than 0. All negative gradients. First line. Okay. So at 10% heavy vehicles, I have 1.96. So this is for up and this is for down. Okay. For up 2.96, for down 1.96. So I'll go to the. So give me the FHV for upward and downward. Yes. FHB. Huh? 8, 3. And for down, okay. Okay. Then, since they are asking for level of service, I am doing operational analysis. Okay, operational analysis means find out VP. This value. Okay, I need this value. So peak hour factor given. Number of lanes. It's a 4-lane highway. I will take 2. Yes. FHV, I have 2 values. So VP will also have 2 values. Okay. Tell me. This is what, up or down? 1767 passenger cars per hour. Okay, and down? One four four three. You just change the FHV, right? Same? No? What? Peak hour factor, how much? What is 0.99? 0.88. Yes, tell me.
Up 1758.65. 66.
Okay. And down? 0.91.
1623.
Okay, they are asking for level of service. Okay, level of service needs density. Density equals Vp upon S. Okay, Vp we have. Okay, I need to decide about S. Okay, which speed I have already? Free flow speed. Okay, but I cannot use the free flow speed until I know I'm in a specific zone. Okay, so I need to decide if I am here or here. Okay, if I am here, then speed equals to free flow speed. If I am here, speed is something else. I need to calculate it. Okay, so this depends upon what is my break point. Okay, now remember, we are doing multi-lane highway. It's a multi-lane highway. What is my break point? Okay, fix. No calculation required. Multi-lane highway, break point is 1400. Clear? Clear? Okay. So look at your values. Are you in front of it or behind it? In front, right? Upward, downward, both. Both are after the break point. So now I need the speed in both cases. Okay, I need to calculate the speed in both cases. I cannot use free flow speed in any case. Clear? Okay. So I need the A value for the speed equation. A value is 1.31 here, and this is the equation for speed. Let me. Okay. Capacity. I need capacity, yes. I need to calculate capacity first. You have the equation for capacity. Okay, you already know the free flow speed. Tell me capacity. Two to three. Okay, now tell me speed.
So what is DC?
What is DC? Tell me. Huh? What is DC? DC means what? Huh? Direct current. Right? Which you need in your head. DC means what? Huh? Density. Look at the figure. What do you call? What did you say DC was? What was it? No?
DC converts.
Huh? DC converter. But this is the exam I'll give you that. How is that? How much? 1.3. How much is S? Yes. What's your question? Table. That table. Just give me speed.
57.6.
Huh? 57.6. Okay. Now one thing here, you can see you use this free flow speed, right? What we have, okay, and you use the capacity what we calculated, okay. But here they are saying adjusted. Use adjusted values. Why didn't we use the adjusted values? These are not adjusted values. These are just the values. Why didn't we use the adjusted values? Anyone? Can you tell me from here? Why didn't we use the adjusted values? Huh? Because it's multi-lane. Okay, because it's a multi-lane highway, there is no adjustment required. Even if I tell you weather conditions are this, work zone is this, fla fla fla, no adjustment required. It's a multi-lane highway. Got it? Clear? So no adjustment because of the type of highway, not because of the data. Clear? Okay. So we were calculating what? Density, right? Okay, tell me density now for each case, upward, downward.
Down 59.46.
59? It's not even the table.
I know.
For S down. This is for down.
I would have S down and up. Yeah. Okay. Yes. Okay, this is for up. This one is for what? This for up. Okay. Up. Okay. Down. 59 point. Because of VP, right? Because of VP. So this is up. Okay. Now give me density. So VP upon S. VP upon S. Tell me. Huh? You use the VP of up and S of up and then both of them for down. Yes. 30. 30.5 and 27.3. Okay, clear. Any question up till now? Clear? Okay, look at the first table. The ranges of density are given. Tell me the level of service. We have densities 330 point something, 27 point something. Where are we? D, right? In both cases, we are in this range. So my level of service is D. Okay? So the gradient, because of the gradient, I had low flow in the downward side. The downward direction had lower flow and more speed. Okay? But it did not have a large impact on the traffic conditions. Level of service D on both sides, that means the traffic conditions on both sides are more or less equal. Okay, you can feel, maybe you can feel the increase in speed, or you can not feel. You can see the increase in speed and decrease in flow, but as far as the drivers are concerned, or as far as the traffic flow is concerned, it's more or less in the same condition. Clear? Clear? Any questions? Okay. Then we have a design example now for a freeway which is in a rural area. The forecasted volume is 2,700. Okay. Peak hour factor is given. We have familiar users. We have 15% heavy vehicles, but now it is heavy mix. And what do we mean by heavy mix? You can see over here. Trailer trucks are more, single unit trucks are less. TRD 0.5. Now, terrain conditions keep on getting more complicated. We have level terrain, but we also have a 2-mile segment which has a length, which has a gradient of 4.5%. Okay, we are looking to maintain level of service C, but minimum is D. Okay, clear? Okay, so this is our aim, but this one can be accepted if, okay, if there is no other option. And they are asking for how many lanes. This is why we call it design analysis. When they are asking for lanes, that means it's a design analysis. Clear? Okay, what is the first step? Tell me. Which is common in all the examples. Free flow speed. Free flow speed for the freeway now. It's a freeway example. Okay, FLW is what? Factor for? Factor for lane width. Okay, we have a table for it, right? You can see the table on the slide. But I need the lane width. Do you see? You will assume, right? You will assume because it's not given. So you will assume, right? Okay. But there is a reason they did not give it. There is a reason they did not give it. What's the reason? What type of analysis we are doing? Design. So you are designing, right? The highway is not there, so how can you have the width? You are the one who is designing. You are asking for lane width, and what good are you? Okay? So you are designing. Okay? We'll assume. Right. So you can assume anything. 12, 11, 10. Whatever you assume, you will carry it with you till the end, and the number of lanes will be according to them. So somebody assumes 12, and they calculate number of lanes, for level of service C. Somebody else can assume 11 and they will calculate number of lanes again for level of service C. So then answers can be different, but the level of service is same. The target is same. Got it? Okay. Now you are designing. You are in the design office, you are designing. Somebody asks you about the lane width. So what would you take? Easy way out is what? Why 12? Because the factor becomes 0. Why the factor becomes 0? Because it is standard. 12 feet is standard value. You take the standard values, don't need the adjustment factors, right? Okay. So I will do the same thing for lane width. And what is FLC? FLC is factor for what? Letter clearance. Okay. So I will do the same thing with letter clearance as well. There is a standard value. Go to the table, you will see the standard value where the factor is 0. But what is my point? You are doing the design. They did not give you any values. I have to assume values. I will assume standard. If I assume standard, the factors become 0. Clear? So the only thing left is TRD. TRD is given. So what is my free flow speed? Next step, again, common. What? FHV. Okay, FHV depends upon terrain, right? FHV depends upon terrain. Okay. How many conditions of terrain we have? 2? 1? How many? 3? Then now which 3? Which 3? Then he said 2. And then he said 1 as well. 2 plus 1 is terrain and gradient. But the gradient can be what? What was it in the last example? Last example was also gradient, right? Up and down. Okay. So that's how it's 3, not 2 plus 1. Okay, that's how it's 3. Okay, we have level, then we have a gradient. But the gradient in 2 directions, upward and downward. Okay. Now listen. Otherwise you will three terrain conditions. 1 level, 1 for upward, 1 for downward. Clear? Clear? Okay. So for level terrain, EHV value, how much? 2. Okay. For gradient case, I am going to use this table because I have heavy mix. Where is it? I wrote it somewhere, right? I didn't write it, sorry. Okay, but it's heavy mix. Okay, it's written there. Just believe me. Okay, so heavy mix means you are using this side of the table. Okay, my gradient is how much? Somebody has a question in front of them. Oh, it's written 4.5%. My gradient is 4.5%. The length is 2 miles. Okay, so 4.5% means I'm here. 2 miles means I'm here, and the percentage of heavy vehicles is 15%. So my value is 3.11. Okay, this is for what? 4.5 upward or downward? Upward. Where is downward? Downward is up. Downward is up. Okay, so this value is 2.04. Okay, so now I have my EHV values. For upward it was 3.11, 2.04, and for level 2 PHV is 15%. So you will give me now 3 values for FHV. Huh? 0.412? How is this possible? %15 means 0.15. And then what? Which one? Seven. Okay. And downward? And level? Huh? For level? How much? 86 again. Okay. Now you can see here for level and downward the values are same because EHV is same. See? 2 and 2.04. Okay. So FHV should be same, right? But this is just by chance because EHV value is not constant, you know. For gradient, EHV is not constant. Okay, in this case you got 2.04. You can have 2.3, 2.6, then FHV will not be same. Got it? Clear? Okay. So in this example, by chance they are same. Okay, but it can be different. Okay. I can give you some practice problem, inshallah, in the example. So here we will do just 2 conditions. One is for level and downward, same, and one for upward. Clear? Okay. Now I'm doing design analysis. For design analysis, the next step is this one. Okay. Now tell me which value is missing. MSF is missing, right? What was MSF? MSF means what? Maximum service load. See, when you read it, then you get it right. Okay. But there's an organization as well in US with the name of MSF. Okay. Now MSF comes from where? For MSF we need to plot the curve. Okay. So what we will do is I will do the calculations with you now. Okay. And you have to plot the curve for the term project as well. So pay attention. The curve is already there. Okay. But I will show you what calculations they have done to plot the curve, and then we can do it ourselves. Okay. So we have to plot this curve. Okay. What is point number 1 on the curve? Tell me. So I want the x and y value for point number 1. Huh? X value is how much? X is 0 and y is free flow speed. Any problem up till here? First point, no problem, right? Then it's a straight line. So I don't need many other points. I'll just go to the end of the straight line. Okay. So x and y, tell me. Break point and free flow speed. Okay. Clear? Break point. I need to calculate the break point now. Okay. Now you calculate the break point. So they are saying use adjusted free flow speed, and then they are saying put capacity adjustment factor as well. Any data about adjustment here? Weather, incident, work zone, driver population. Driver population is mentioned, but they are saying all familiar. Driver population is mentioned, but it is mentioned as all drivers are familiar. Familiar means no adjustment. Familiar is a standard. Okay. So even this is why I didn't write it here, but the question does not mention anything which requires adjustment. So what we will do, free flow speed is same what I already have, and CF, capacity adjustment factor, there is no adjustment. So factor is gone. This factor is gone. So how much is the break point? Tell me the break point. Okay, so point 1 and 2 solved, right? Okay, now we'll jump to the last point. Okay, last point of the curve. Tell me the x and y. X is capacity and speed. We don't know the values, right? Capacity and speed, we still don't know the values. For capacity, we have any question? Okay, so how much is the capacity? Two, 4, 3, 6. Okay, but there's a limit. Capacity has a limit. What is the limit? How much? 2400. Your value is more than 2400. What to do? Obviously you guys are wrong, right? We will take the limit. Okay, we'll take the limit. So capacity is 2400. Okay, so I know the x now, I need the y. Okay, like why are you here? Got it? Just note down that the a value is given here for freeways, which is 2. Okay, because we need it. We will use this equation. You can see a is required here. A is 2. Okay. Adjustments, I already told you, they are saying use free flow speed adjusted, capacity adjusted. We don't have any adjustment, so we will use whatever we have. Okay, clear? Clear? Okay, one more thing here. Vp is my x value. Vp is my x value. At the last point, what is my x value? Capacity. So only for the last point you will put Vp as your capacity, only for the last point. Okay, capacity becomes Vp only at the last point. Okay, so you will put capacity here and then here as well. So tell me, what is the speed on the last point? How much?
53.3.
Anybody else? How much is your free flow speed? 73.6. How about you? How come you went to 33?
53.3.
53.3. Okay. Thanks. Or keep it 3. Okay. So I have now the first point, the second point, and the last point. Okay. From the first point to the second point, it's a straight line, no problem. You know x and y here, you know x and y here, you will just join it with a straight line, no problem. Then from point number 2 to the last point, you know the x and y, okay, but it's a curve. It's a curve, okay. So now you have to draw a curve between 2 points, okay. I know you guys are very artistic, you can do it, and students have done it, okay, even on the height. They don't know the radius, they draw the height, okay. So you can do it, I know, okay. I have full confidence in you, you will do it and it will be wrong. So we will not do it, okay. We need at least 3 points to draw the curve, okay. Otherwise everybody will be drawing their own curve. This is point 1, this is point 2. Somebody will draw the curve like this, somebody will draw it like this, and so on and so forth, okay. We don't want this. We need at least one more point, okay. So we'll calculate point number 3 here. Now point number 3, I know it should be between the second and the last, right? Should be between the second and the last, okay. So I know the range of x, okay. Point number 2, x was break point. Point number the last point, the x is capacity, okay. So I know x is between these two values, okay. I am taking, just for an example, 1500. But somebody takes 1200, fine. 1600, fine. You can take more than 2 values. You can take 1500 and then 1600 and then 1700. More values you take, your curve will become more accurate, okay. More values will make the curve more accurate, okay. I am taking 1500 here, so we'll put now in the equation of S, Vp as 1500. How much is S now? Tell me. Okay, so now at least I can draw the curve. If you want more points, you can do it, no problem. Okay, clear? Clear? Okay. Now why I am plotting the curve? Because I want maximum flow rate at level of service C and D. I want maximum flow rate at level of service C and D. This is the example in which they plotted the curves, okay, and they made the lines for level of service, okay. So you can see the lines for level of service. At each line you see the value of density, right? Okay. The line which is level of service C, the density is 26, right? And the line which is for level of service D, the density is 35. How do we plot the line? Take the density and do its inverse. So it will become tan theta for the line. Okay. So if you want to plot the line of level of service C, take the inverse of 26. How much is it? Inverse of 26. How much? Okay, so here my tan theta is how much?
0.038.
Okay, this is for the first line. For the second line, which is this one, the density is 35. So now you have to do the inverse of 35. What is the inverse of 35? How much? 28? Okay. So you now found the tangent theta, you draw the lines, you already have the curve, you draw the lines wherever the line is intersecting the curve. So you see the C line is intersecting the curve here. So this becomes my maximum service flow rate for C, and you can see the value over here. Okay, the line of D intersects the curve at this point. So you take the X value at this point, this becomes maximum service flow rate for D. Okay, the intersection of C, MSF of C, intersection of D, MSF of D. Okay, now I will just explain the rest of the calculations, so pay attention. I have to find out number of lanes. The only thing which was remaining was MSF, okay, which I got from the curve now. So I'll put the value of MSF of C, because D was a minimum. I don't want minimum right now. Okay, I'm doing it for the one which is the target. Okay, like you start the course with the thinking you will get A, and then you settle for whatever. Okay, so we had three terrain conditions: upward, downward, and level, right? Okay, so for level, for upward, downward, okay, you can see for level and downward the values are almost same. Okay, this is for the upward. Okay, now in both cases you got 2 point something in all the cases. How many lanes you will give? How many lanes you will give? 3, right? Because if you give less than what the equation is showing, then you're not meeting the target. You're not meeting the target. Okay, if you provide 3 lanes, right now you need 2 point something. If the traffic increases in future, maybe it will go up to 3. So even in future you are safe. You will still have level of service. Somebody may say, but D is also acceptable. Why don't I put 2 here? So I will get, instead of C, I will get D, which is also acceptable. Okay, but again, the same thing. D is acceptable right now, but maybe in future something unexpected happens, traffic is more, you will not even have D. Okay, so we will give 3 lanes. Okay, got it? One more thing. If any of these values was 1 point something and the other one was 2 point something, how many lanes? If one value was 1 point something and the other value was 2 point something, how many lanes you will give? 3. Why? 2. We will give 2 and 3. No? Because it is the maximum, that's why. But why don't we give 2 different number of lanes? What's the problem? 2 in one case because 1 point something, and 3 in other case because 2 point something. What's the problem with that? Look here. What's the problem with that? It's upward and downward, right? So there are 2 different directions of the same height. We don't do 2 lanes here, 3 lanes here. Got it? We are saying 3 lanes are required here and 3 lanes on the other side as well, even if it doesn't require. Okay? 2 directions don't have any conflict between them. You don't have any difference between them. Okay? So even if one direction says 1 point something, the other one says 2 point something, and you are rounding off to 3, then the other one should be 3 as well. Okay? It's common design practice. Got it? Clear? Not convinced? Wasting money, right?